Hi, I'm Amy Murray, Public Relations and Marketing Communication Manager at Biosoil Enhancers. Welcome to the adventure of Biosoil Enhancers and the technology of Sumagrow. Every day we are committed to providing the highest quality products that are soil friendly, people friendly, and future friendly. We're often asked what the technology of Sumagrow is and how our products are made. So we'd like to take you on a tour of our facilities. You'll meet the team, visit our labs, and learn about how our products are made. First, let's meet the team. Now that you've met the team, we're going to show you the process of how products containing Sumagrow are made. We're going to take you from the lab, to the greenhouse, to the field, to the customer. Let's get started.
We're really excited to learn that there is a company in Hattiesburg that manufactures bioenhancers and microbial-based preparations to enhance plant health.
The process begins in the laboratory, where microbes are screened, isolated, purified, and functionally characterized. All bacteria are identified down to the molecular level.
The Sumagrow is a polymicrobial multifunctional formulation which consists of the active bacteria which, when it enters into the soil, it associates with the plant roots and makes all nutrients available to the plants during the growth period.
The formula, consisting of polymicrobial products that are synergistic, complementary, and multifunctional, is stored for long term in a deep freeze at -71 degrees Celsius.
And when once we wanted to make in a large quantity, so the first we go for the production of mother culture.
Before mass production can begin, a mother culture must be created. The pure culture previously collected and stored is taken from storage and subcultured on Petri plates, where it begins a process of transference, incubation, and shaking until finally a larger quantity has been collected in a large conical flask, which is then placed on the centrifuge.
The company has got all the infrastructural facilities to produce the mother culture in small quantity as well as in a large quantity.
The sediment bacteria is then cooled and blended with humic acid. Each step is completed in a sterile environment, maintaining quality, uniformity, and purity, which is routinely checked by a quality control manager.
And so then we incubate our culture and we check for growth. In the tubes it'll be cloudy, which would indicate positive growth. And I also put some of the product on Petri plates, which we will be able to look at individual colonies that way.
So as the bacteria are grown from the mother culture, they're scaled up sequentially in volume. This is our final volume before we move to the bioreactors.
Once the microbes are sourced, we turn them over to production, where they are grown, blended, bottled, and shipped. Let's see how it works.
So the last phase in our industrial scale-up of our microbial growth involves these bioreactors, in which we take a small inoculant of each bacteria, place them in a large fermenter, and allow them to grow up to volume. This allows us to keep up with supply and demand in large quantities.
From the bioreactors, the microbes are taken to the mixing process, where they will be blended with the raw food that will sustain them on their journey from the plant to the customer.
The microbes require certain nutrition, they require certain conditions such as pH in order for them to sustain themselves.
When the raw food or humic acid arrives at the plant, the pH level must be reduced to the proper level. Using a state-of-the-art automation system keeps the process continuous, eliminating the need for constant calibration.
What you see here are the tanks in which the raw food, which is humic acid, that gets stored. After that, what we need to do is use our network of sensors and valves, pumps, etc. We use that to pump the fluid into this while we continuously monitor various process parameters. And what we do is we mix here and reduce the pH of the humic acid to the desired level.
At this point, the product is ready for distribution. Each specific formula packaged and labeled and prepped for shipping and handling.
In addition, through vigorous research and development, we continually work to make new products to meet the needs of our customers. Research and development remains fundamental to ensuring that we stay in front of the developing needs of our customers and ready to assist them in meeting the demands of growing regulations. Let's talk with the Director of Research and Development, Dr. Litha Kumari, to find out more.
As the Director for Research and Development, I have been developing new products. Right now in BioSoil we have about 9 new formulations. These 9 new formulations will be tested in the greenhouse with very important crops like corn, tomato, soybeans and other vegetables, and then we will evaluate which one is the best, or if all of them are good, then it goes for the specific countries international wise and also in United States.
Testing of the product's efficiency begins in the greenhouse before being tried in the field.
So basically we have a few control experiments that we set up with treatment groups. So we're looking at the differences between said controls, said treatment groups and efficacy of our product. Here we are today in a field in Mississippi where we're looking at the efficacy of our product on tomato plants. We've worked also with corn and soybeans locally. This year we're getting ready for fall crops where we're looking at kale as well as collards and a few other common fall crop vegetables. We also do nationwide as well as in different countries, so we've moved globally. I just got back from a trip from Guatemala where we looked at sugarcane and banana plantations and the use of our product with their soil type.
When it turns over, you're incorporating the microbes into the soil, so then the roots can come out and
So really it's not about just using it in one different soil type, it's the myriad of different soil types and the benefits that you see from our product really across the board. What I do is really set up the experiments and help with some of the implementation of it. So we look at control groups and treatment groups with different fertilizer regimes with and without our product to look at how our product reacts across different soil types and across the board with different crops. So that's really one way that our product's able to benefit a number of ecosystems around the world, is that it's not just about the crop you're growing or the land that you're growing it on. It's about enabling the soil to become healthier for the long-term viability of the land and of the crop.
BioSoil Enhancers has partnered with the University of Southern Mississippi to make Sumagrow even better. Their collaborative research focusing on 2 aspects: testing different strains of Sumagrow with different plant types, and to improve the overall shelf life of the product.
We're looking at how individual strains within Sumagrow preparation survive over time under different environmental conditions. So we tagged a couple of strains from Sumagrow with antibiotic resistance, and then we put them into humic acid. And so these individual samples of humic acid were stored over time at different conditions: room temperature, under refrigeration, outside at ambient temperature, and at higher elevated temperature. And so what we do then is we use a special assay that we designed, which uses this 96 well microplates, where we can recover individual strains and quantify their population and see how these strains survive over time under different conditions.
You know, in the end, this is really not about the equipment. It's not about the bioreactors. It's not about all the microscopes and lab equipment. It's about leaving a legacy for future generations. It's about making a meaningful difference, okay, for those yet born. And so the soil, this soil, is our most precious asset. It sets the table for our food. It grows this grass, okay, and takes care of the plants and trees to produce oxygen we need to breathe. It's our survival. And unless we take care of it, we can have significant problems. In the year 2050, we're going to need as much farm-grown produce as we've grown since the Industrial Revolution. Where does it come from? Where does the nutrient base come from? This is our adventure, our journey, and we'd like for you to join us.